Hello viewers, I am Kausalya. Today we are going to solve problem number 4 under the topic lead compensator using Bode plot. So to start with, you will get a clear idea if you go through the procedure of how to design a lead compensator in Bode plot. I'll give the link in the description. Now, the problem is design a lead compensator for a unity feedback system with open loop transfer function. This is the given transfer function to satisfy the following specifications. The first one is velocity error constant is greater than or equal to 50 and phase margin is greater than or equal to 20 degrees. So this is the given transfer function, right? And the type of feedback is unity feedback. Now we are asked to design a lead compensator such that the phase margin should be greater than or equal to 20 degrees, right? And this velocity error constant kV is given here. The main purpose is we are going to find the value of k using this kV. Okay, this is our step number 1 here. So the step 1 is finding the value of k. So kV is greater than or equal to 50. For our consideration here, we are taking the value of kV as 50, okay, equal to 50. By definition, kV is given by limit s tends to 0, s into g of s. G of s is the given transfer function. So just substitute the values here. And finally, when you solve, the value is kV is equal to k by 5, right? So the value of kV is given as 50, right, in the problem. So just substitute the value over here. And finally, the value of k is 250, right? And now the step 2 is to draw the Bode plot for the given system. So this is our given transfer function. Just now we had calculated the value of k. So just substitute it over here. So this is our transfer function now. So again we are arranging the transfer function in the standard form. So here s plus 1, it doesn't make any difference, right? So here we are having s plus 5. So I am taking this 5 outside. When you take this 5 outside, this expression gets modified as s by 5 plus 1. Right. So when you simplify, finally we are getting a transfer function like this. That is 50 divided by s into 1 plus s into 1 plus 0.2 s. Now for this transfer function, we are going to draw the Bode plot. So the first step is replace s by j omega, right? Then we are going to find the corner frequencies. So we have to just take the reciprocal of the coefficient of the imaginary term. So here the coefficient of omega is 1. So 1 by 1 is 1 again. And here 1 divided by 0.2 is 5, right? You have to give the name based upon the ascending order. So here this is 1. So it is omega c1 and 5 is the next higher number. So omega c2 is given for 5, right? And table 1. So table 1 has 4 columns, right? Term, corner frequency, slope and change in slope. So how to arrange terms in the table? So the first priority should be given to constant along with individual omega. So here we are having 50 and in the denominator I am having j omega. So we have to write this term first. Right, and the next one, the remaining these two terms have to be arranged on the ascending order of the corner frequency, right? So you see first this term is written and the next corner frequency is 1, right? Which term contributes this one? This one is contributed by this term, 1 divided by 1 plus j omega, right? So again the next corner frequency is 5 and this 5 is contributed by this term, 1 divided by 1 plus j 0.2 omega. So here we had arranged the terms, right? And the next step is, you see here we are having omega in the denominator. So the slope contribution is minus 20. Similarly here also it is in denominator minus 20 and here also the same case, right? And the next one, change in slope. So here for calculating the change in slope, here we have to move this minus 20 downwards and this minus 20 to the right hand side. So here it is minus 40. Again when you move this minus 40 downwards and again we are shifting this minus 20 to the right hand side and here it is minus 60. Right. Now we have to choose two frequencies, omega L and omega H. That is omega L should be less than omega C1 and omega H should be greater than omega C2. So here I had selected 0.5 and 10. Again repeating the same thing. There is no compulsion that you should take 0.5, even you can take 0.1, and here also even you can take 100 or 50. Okay, that won't make any difference in your Bode plot. So the next step is we are going to calculate magnitude. So for omega L and omega C1, here we are going to use the same formula, that is we are going to consider only constant with individual omega, right? Since we want the output in decibel, here we are adding 20 log, that's it. So the value of omega L is 0.5. So you just substitute in this expression and get the answer. Similarly, do the same thing for omega equal to omega C1. Here the value is 1. So just substitute the value as 1 here and find the values. And for second corner frequency, right? So for second corner frequency, you see this is the formula. That is change of slope from omega C1 to omega C2. That is where during the second corner frequency there is a change of slope, right? So what is the value of change of slope? You see, this is our second corner frequency, right? So from omega C1 to omega C2, what is the change of slope? Here we are having this minus 40, right? This minus 40 is moved over here. So change of slope is minus 40. So minus 40 into log of, you just substitute these two values and finally find out the answer here. And the next one is at omega equal to omega h. So here again, change of slope from omega C2 to omega h into log of omega h by omega C2 plus the previous value of a, right? That is when omega equal to omega C2, what is the magnitude? So just substitute the values accordingly and finally the magnitude is minus 12 dB, right? So just I had listed out in the form of a table so that it will be easy for us to plot, right? And the next thing is writing an expression for phase plot. So again we will write the problem one more time, that is 50 by j omega into 1 plus j omega into 1 plus j 0.2 omega, right? So here since omega lies in denominator, this contributes 90 degree. When I move this term to the numerator, that becomes minus 90. Again same case here, tan inverse of omega by 1. Again I am moving this to the numerator, so minus tan inverse of omega. Again here tan inverse of 0.2 omega. When you move to the numerator, minus tan inverse of 0.2 omega, right? So after writing the expression, kindly include all these omega values. Apart from that, you can include the between values also. That is between 1 and 5 you can consider 3, and 5 and 10 you can consider 7 or 8, and even for some higher frequencies also, that is 12 or 14 also you can calculate. When we have some 6 or 7 values, then our phase plot will be more accurate, right? So we had considered these values. Just substitute the value of omega over here and write down the answer here, right? So now we are going to draw this phase plot and magnitude plot on a semilog sheet, right? So you see, this is our semilog sheet. So x-axis stands for omega. Here I had started from 0.01 to just up to 100, right? And here y-axis, this left hand side y-axis stands for magnitude in dB. So here I had selected the values like this, and again on the right hand side of y-axis, this stands for phase angle, and here you just keep it in mind, these are all minus signs, right? Minus 80, minus 100 and minus 120, like that. And after taking the values, you have to write the scale. It is mandatory, right? Now we are going to draw the magnitude plot for the uncompensated system, right? I hope you people know how to draw the magnitude plot, but anyway, I'll explain 1 or 2 steps. You see, this is our expression for magnitude, right? So here the first point is at a frequency of 0.5, the magnitude is 40 dB. So here at a magnitude of 0.5, right? So here lies our 0.1. So 0.2, 0.3, 0.4 and 0.5. So at 0.5, what is the magnitude? It is plus 40 dB, right? So you see, this is our 0.5 and here the magnitude is plus 40. So just keep a point, right? Likewise, you just do the remaining things. You see, I had marked it using a pencil over here. Now we are going to join these dots by using a scale. Wait, let me show you. The next thing is we are going to draw the phase plot, right? So here again the first point is at point 1, the angle is minus 96. So you see this is our minus 80 here. So this is 84, 88, 92 and this is our 96, right? So here lies our minus 96 and the value of frequency is 0.1. So here is our 0.1, right? So at 0.1 and here lies our minus 96, right? That is just above 100, this line. So when you move across, you see here is our first point, right? You see at 0.1, this is 0.1. So at 0.1 and the respective angle in the line is minus 96, right? So likewise, you just plot the remaining points. Here I had again used pencil to keep these points, right? Now I am going to join these dots using freehand. So this is our phase plot of the uncompensated system and this is the respective magnitude plot of the uncompensated system, right? Am I making things clear? These are all the basic things we had already studied in Bode plot, right? Now we are proceeding to the step 3. So in step 3, we need to calculate the phase margin, right? So how to calculate the phase margin? You see, our magnitude plot intersects 0 dB line at a particular point. So from this point, just draw a line till it meets our phase plot, right? So at that point, you just measure the angle. You see, it is exactly equal to minus 224. So this is our phase angle, right? So make a note of it. So just now we had calculated the angle, right? It is minus 224. Now the phase margin is given by 180 degree plus this angle pi GC. So 180 minus 224 gives you minus 44 degree. So whenever the phase margin or gain margin, okay, whatever may be, if they are negative, if any one of them is even negative, then the system is unstable. So here we are having a negative phase margin, therefore the system is unstable. Therefore we are moving to the lead compensation, right? Then the next step is, now we are going to find the new phase angle, right? So here the desired phase margin is, it should be greater than or equal to 20 degrees. So here the maximum lead angle is given by this formula, gamma desired minus gamma obtained plus epsilon, right? Initially the value of epsilon should be taken as 5 degrees. So here the desired phase margin is 20 and the obtained phase margin is minus 44 and epsilon is 5. So when you calculate, the phase angle is found to be 69 degrees. Since the value of this angle is greater than 60 degree, we are connecting, that is, we are making the compensator as 2. Okay, we are having 2 compensators. So we are dividing the angle. So 69 by 2 gives you 34.5 degrees, right? The next step is finding the transfer function of the lead compensator. So to find alpha, this is the formula. Just now we had calculated pi m, right? So just substitute in this formula and find the value of alpha, right? Then the dB magnitude, that is magnitude corresponding to this frequency, is given by minus 20 log of 1 by square root of alpha. So here we know alpha, so just substitute it over here and the magnitude is minus 5.5 dB, right? So again now we are moving to our Bode plot. So just now we had calculated the value of magnitude as minus 6 dB, right? So here this is our minus 6. So just make a point, okay? Then using scale, you just check at what point does it touches our phase plot, right? It touches the phase plot, magnitude plot at this point, right? Even if you want, you can draw a line using a scale. Okay, I don't want to make the plot too much of clumsiness, right? So here I had to keep the dot like this and just draw a line downwards. Okay, when you draw a line downwards, you see the value of omega m is found to be 7.8 radian per second. Make a note of it. So here omega n is 7.8 radian per second. Even if you get the value of 7.6 or 7.9, it's okay, right? Now just substitute it over here, and finally the value of t is 0.24. Then the transfer function of lead compensator, this is given by this expression, right? So just take LCM inside, and you see the common terms are getting cancelled, and finally we are having an expression like this. We know the value of alpha, we know the value of t, so just substitute it over here, and finally this is the transfer function of our lead compensator, right? And step 6 is finding the open loop transfer function of the compensated system. So this is the given transfer function, right? And this is the transfer function of lead compensator. And a compensator is always connected in series with the transfer function, right? Now, how to find the open loop transfer function? Here there are two blocks, and these two blocks are connected in series, so just we need to multiply. So when you multiply and simplify, finally this is the transfer function of the compensated system, right? Now we are proceeding to the next step, step 7. We are going to draw the Bode plot of the compensated system to verify whether the phase margin is greater than or equal to 20 degrees, right? This is quite a bigger problem, right? So there is no other way, we have to proceed. So here again repeating the same steps, replace S by j omega, right? And we have to calculate the corner frequencies. So here again we have to take the reciprocal of the terms, reciprocal of the coefficients of omega. So you see here totally we are having 4 corner frequencies, right? So as usual, while arranging, the first place should be occupied by constant with individual omega, and the rest of the term should be arranged in the ascending order of corner frequencies, right? So here I had arranged the things based upon the corner frequency value, and next as usual, when omega lies in denominator, this contributes minus 20, and when omega lies in numerator, this will contribute plus 20, but here we are having omega square, so plus 20 gives you plus 40 over here, right? Similarly here you see omega lies in denominator, omega square, therefore minus 40. As usual, just shift the things and calculate the values, and we are having the change of slope like this, right? If you have any doubt in making the table and calculating the change of slope, kindly go through the previous videos which I have made in Bode plot, right? Next again we have to select omega L and omega H, right? As usual, select the values as you wish, and we are going to calculate the magnitude. So for calculating magnitude for omega L and omega C1, you have to consider only constant with individual omega here, right? So just substitute the values and find out the magnitude, and from omega C2 the formula gets a bit changed. Change of slope from omega C1 to omega C2 into log of omega C2 by omega C1 plus the value of A when omega equal to omega C1, right? So calculate the values, and likewise you just proceed gradually, and finally we are calculating the values up to omega H, right? Again, when I start explaining these things, it will again take much more time. So only I am requesting you people to go back to the Bode plot session and watch the videos. You will get a clear idea there, right? So here after calculating all the things, right, I had made a small table, right, for different values of omega, what is the value of magnitude, right? Now we are going to phase plot. So for calculating phase plot, again this is our expression, right? So as usual, here I am having a term in the numerator but with a square term. So nothing but place a 2 in front of it. 2 tan inverse of 0.24 omega by 1. Right, and omega, this contributes minus 90, and this term contributes minus tan inverse of omega, and here again minus tan inverse of 0.2 omega, and here again 2 into tan inverse of 0.067 omega, right? Again select the values which you have already used in magnitude plot. Apart from that, you can select in between values and even higher values also, right? Calculate the values of phase angles accordingly, right? Just substitute omega as 0.1 over here. And what is the value of pi? Just write it over here. Okay. Likewise, you just finish the remaining things. And now we are going to draw our compensated Bode plot. Right. So here I had kept the dots in red pen, right? These are the dots of the compensated Bode plot, right? Now I am going to join all these 6 dots here. Wait, let me join and show you. So you see, this is our Bode plot of the compensated system, right? So it is must to write the value of change of slope in each and every line, okay? It is mandatory. So can you compare, right? This is the Bode plot of uncompensated system and this is the Bode plot of the compensated system, right? So when you extend this line downwards, it will meet our compensated system. So in order to show the difference, I'll join these 2 points using this dotted line, right? So now we are going to draw the phase plot. You see, this is our phase plot of the compensated system and this is the phase plot of the uncompensated system, right? Now we shall calculate the phase margin and we will check whether it meets the specifications. So again, how to calculate phase margin? This is the Bode plot of compensated system. So it crosses 0 dB line at a particular point, right? So from this point, just draw a line downwards. Okay, it will meet our compensated phase plot at some point. At that point, you just kindly check what is the respective angle, right? This is what we are going to do. Wait, let me draw the line and show you. You see, I had drawn the line, right, from this intersecting point to downwards, and this at this point when you measure the angle, you see when you move gradually, here the angle is found out to be minus 140 degrees, right? So just make a note of it. So now the value of this pi gc naught is minus 140. Again substitute in the formula 180 degree plus pi gc naught. So that gives an answer of 40 degrees, right? So here the expected value of phase margin is, it should be greater than or equal to 20 degrees, right? But here now we are having 40 degrees, so it is more well and good. Therefore, in conclusion, the phase margin of the system is satisfactory. Therefore, the design is acceptable, right? And in result, you just highlight these 2 transfer functions, that is transfer function of a lead compensator and then the open loop transfer function of the lead compensator system, right? Here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.